So for this problem, they want us to, if you've done this part, you know that the correct answer for part B is to form 5 different groupings for these people. Now these are just how much excess weight they have. Those aren't random numbers. So what I did is I sorted all these numbers in order, and then I just grouped them with similar groups of 4. So it's not perfect. I mean, who's to say that this 34 is that much different than that 35, or that 29, 30, but they wanted us to break them up into similar groups, so this is what I did. Now what I'm going to do is I need to assign these people in these groups to one of those 4 treatments. Okay, so each person in a group is going to get assigned to a treatment. So a number of ways to do this, and on the next slide I've got this set up. So I assigned numbers 1 through 4 to each of these people in each of the groups. Okay, and then I've got my treatments listed here. So first off, I guess is there's a couple of ways to do this. I guess what I'm going to do is I want to look at just the single digits, and so when I enter my table, I'm just going to look at a single digit, and if it's a 1, 2, 3, or 4, I'll use it. If it's another number, I'll discard it. So I'm going to shut my eyes and let my pencil fall wherever. So it's on this row. So the first number is a 0. I don't have a number 0, so I'm going to skip that one. The next number is a 3, so I go to group 1, and Franken is group 3, so I'm going to assign him to treatment A, or her. I guess these are ladies, aren't they? Alright, so that person, Franken's been assigned. Okay, now the next number in that row was, if I can find my spot again, let's see. I mean, it doesn't really matter if you don't find your spot. You could always hear it. I think I was using this one. So the next number is a 6. Well, let me finish that statement. It doesn't really matter where you keep going as long as you don't introduce any bias. The nice thing about continuing where you left off is that way you're not introducing any kind of bias. You're going with the randomness of the table. So my next number is a 6. Can't use it. 9, can't use it. Another 9, can't use it. I can't use a 7. And just notice I just jumped over. Can't use a 7. I'm going to use a 1. So person number 1 in the second group, Sanders, is going to also get treatment A. Okay. Next number is a 0. Can't use it. Can't use 8. Can't use 0. Now I can use a 2. So in group 3, Pryor is going to get selected. I'm going to use Pryor. I'm going to use Sanders, I said. So Pryor goes to group A. Okay, next number is let's see. Shouldn't be doing this early in the morning. I can't use the 0. I can use the next 2. So in this, let's see. I guess if Spectre is the next person, right? So Spectre I'm using. Let's see. I'm going to mark my place in the table so I know. Spectre. These are all group A people, right? And I've got this last group. Let's see. So the next number is a 0. The next number is a 2. So in this last group, Wyden's going to be assigned. Okay, so that's all the people that are going to get assigned to treatment A. I have one person from each grouping, each of the 5 groups. Okay, and I can go back and I'll do the same thing to get my patients or subjects for treatment B, and you can just keep going on the table. Let's see, so I have a 9, I have a 3, so person number 3 has already been selected out of the first group, so I can't use him or her. So person 8, no 7, no 0, no 9, no 1. Alexander is going into treatment B. Okay, I hope this gets you. I won't walk through the whole thing. But this is one way to randomly assign patients to treatment groups, okay? And we're trying to cover for the blocking thing because the blocking issue and weight loss issue, because one person from each weight group will be in each treatment. So then maybe we can compare treatment loss, average treatment loss to within the groups. A lot of ways we can analyze this. Okay, that of course has to be on this. So I hope that helps.